Indexes are the fundamental tool for querying documents in a Fauna database. Since Fauna does not currently provide table scans, indexes are required for any queries where you don't already know all the references of the documents you need. Indexes are also the way to search and sort documents from a collection. So let's create all the indexes we will need in our application by using the Fauna shell from our dashboard. From here, we can use the Fauna Query Language, or FQL for short, and type create index to actually create a Fauna index. Then, set the index name to all posts, specify the source collection for this index using the collection function, and pass the name of our collection as a string. And click Run Query to create the index. From the console above, you can see the query we just ran and its result. Now that we have an index, let's actually use it to retrieve documents from our collection. So type the following query, paginate, match, index, and then pass the name of the index to it. This query uses the index function to specify that we are working with the all post index. Then match function is used to search the index, producing a set of results. And the paginate function is used to paginate our query and return a page of results at a time. When you run this query, as you can see, we get, as a result, a data array with the references to all the documents from our blog post collection. We can then pick one reference to fetch the details for a specific document by using the get and the ref functions, and by specifying the collection from which we want to fetch the document. As you can see, this time we retrieve all the data from our documents. Now, what if we want to fetch the content of every document and not just their references? To do so, we can use the map function to process each of the paginate results with a lambda function. Because our index only returns one value for each document in the collection, which is the document reference, our lambda function will take only one variable as an argument, which we can call ref. Actually, you can give it whatever name you like. Then, within the lambda function, we can simply call the get function to retrieve the document specified by the ref variable. When we run this query, we get the same data array with all our documents, but this time populated with our documents data and not just the references. Let's keep going and create a new index to maintain a unique constraint on the slug property of our blog post document so that we can make sure we can't create multiple documents with the same slug, as this value is going to be used by our application to create the route to the blog post. In other words, we can't have two blog posts with the same slugs. Otherwise, we won't be able to tell which one to display. Doing so with Fauna is actually pretty simple. We just need to create a new index, give it a name, specify the same source as before, and add an array of values. Inside that array, we specify the slug field which exists in the document's data field. Finally, we set the unique property to true to enforce the unique constraint on the slug field. Then run the query to create this new index. Next, use Paginate to query our all slugs index. As you can see, the slug is the only field returned by this query. Actually, we don't need to return anything else as we won't use this index to search for documents. Now, if we try to create a new document in our collection with the same slug as an existing document, we get the following error. Document is not unique, which is great because that's what we wanted. Next, let's move on and create our next index. Let's call it post sort by published at ASC, as we will use it to sort the document in the blog post collection by the published at field in ascending order. Then, pass to the values array the published at field and the ref field so that we can easily retrieve the documents using a lambda function and the document's reference as we did before. Run the query to create the index and check in the console that it has been created successfully. Next, use Paginate to create this new index. As you can see from the results, the documents are sorted automatically by the published at field in ascending order. And for each document return, we get the published at value along with the document's reference. And if you want to sort the result in descending order, we can simply set the reverse property to true for the publish at field when creating the index. As you can see, we now get the results sorted in reverse order with the most recent document first, which is actually more useful for our use case as we'd prefer to have the most recent blog post render first in our application. As before, to get the document's detail and not only the publish at field and the reference field, we can also use the map method with a lambda function. But this time, we need to specify two variables as our index is returning two fields. Then we can use the get and ref functions to fetch our document with the reference document. As you can see, we get all the document's data from our query, and everything is sorted just as before. Let's actually create a similar index, but to sort our document by the updated at field instead of the published at field. Now, let's have a look at how to create an index to search document from our collection using a specific field. Let's call this new index post search by published, as we will use it to search document in the blog post collection by the published field so that we can retrieve only the posts that have been published, for example. To do so, specify the published field inside the terms array and run the query to create the index. Next, let's run a Paginate query to use this index and only fetch the blog posts that have not been published yet. As you can see, it is working fine as we get one document from this query, which is the only one that I've not published yet. For our last index, let's specify a different search term so that we can search blog posts by slug. So let's call our index post search by slug. And specify the slug field in the terms array. And run the query to create the index. Now, if you visit the Indexes tab, you will find all the indexes we have created. You can even check and edit the parameters of a specific index by clicking on Settings.